Alright, the next operation on rational expressions is adding and subtracting. Adding and subtracting is actually a little bit harder than multiplying, and the main reason for that is you need common denominators. If you remember, for fractions, we'll do a couple of examples here. To add these two fractions, we need to have common denominators. In this case, it would be 12. So if we make both of these fractions to have a denominator of 12, this would be 8, this would be 9, and add them, you get 17 over 12. Okay? Now, when you do fractions, you can find a common denominator. It doesn't need to be the lowest common denominator. We could have done this using 24 as a denominator, and then you could simplify the final fraction. You can't do that with rational expressions. You really need to find the least common denominator. Okay, this is critical. Find the least common denominator. Okay, so let's try a few questions. We're going to find the lowest common denominator. That's key. Okay, then we're going to write the expressions, then we're going to add or subtract, and we're going to list non-permissible values. So let's take a look at this fraction. What would be the least common denominator for 7 and 3x? Well, if we want a factor that both of these go into, you're going to need to have 21x. So that would be our common denominator. What did we do to the 7 to get to 21x? We multiplied by 3x. So it's going to be 2x times 3x, which is 6x squared. Okay, then let's do the same thing with the other fraction. What did we do to 3x to get to 21x? Multiplied by 7, so we need to multiply the top by 7, and you get 35. So if we add that, we're going to get 6x squared plus 35 all over 21x. Okay, and what is my least common denominator? Sorry, not my least common denominator, what am I talking about? What is my non-permissible value? X cannot be 0. Okay, and what you should do then is you should quickly check, is there something that we can divide into each of those? Is there a common factor? Okay, and if you look closely, you'll see that there is no common factor. Sorry. There's no number that goes into each of those. Okay, let's try the next one. All right. What is the least common denominator, lowest common denominator? Well, a number that both 5 and 4 go into will be 20. And then I need a number that a will go into, so I need an a, and I also have a b squared. Okay, so what did I multiply 5a to get 20ab squared? I multiplied by 4b. So if I multiply the top by 4b, I get 16b. Okay. Now what did I multiply 4b squared by? I think that's 5a. So if I multiply the top by 5a, I get 15a. So now I can subtract. I have a denominator that's 20ab squared, and in the numerator I get 16b minus 15a. Again, I'm checking for common factors that I could divide out here, and I don't see any. There's nothing that goes into 16, 15, and 20. There's no a's in common. There's no b's in common. Okay? A cannot be 0. B cannot be 0. Alright, so that's the general idea. Let's get a little bit tougher each time now. So now, let's try to figure out what the least common denominator is here. And a lot of times our instinct is just to multiply these and go with 48x cubed. Well, that in this case would work, but I want you to get in the practice of finding the least common denominator, the smallest number that both of these will go into. Well, what's the smallest number that 8 and 6 will go into? That would be 24. What's the smallest number that x and x squared will go into? That would be x squared. So, how many times does 8x go into 24x? What did I do here? I multiplied by 3x. So I'm going to multiply the numerator by 3x. And I'm actually going to write this step out. So I'm going to multiply 3x times x plus 5. Okay? Let's look at the second one. What did I multiply 6x squared by to get to 24x squared? By 4. So let's multiply this by 4. 4 times x minus 7. Okay, now let's clean this up. Okay, we're going to get 3x squared plus 15x. Alright, that's multiplying the 3x into both of these terms, plus 4x minus 28. And that is all over 24x squared. This can still be simplified further. I can collect like terms in the numerator. Okay. And that's all over 24x squared. Now when you get a little bit more in depth with these, we should consider whether we can factor this, because sometimes there will be a factor that can cancel. That's pretty rare though. Very quickly, do you remember how to tell if you can factor this? Alright, if you do b squared minus 4ac, okay, that's 19 squared minus 4 times 3 times negative 28. So 19 squared, what the heck is 19 squared? Is it 361, I think? And then 4 times 28 is 112 times 3 is 336. So this is 697, which is not a perfect square, so you know you can't factor that. Okay? So we're done, except that we need to say x cannot be 0. Okay? Let's try another one. Okay, what is my LCD here? Looks like I need a 15. Looks like I need c squared and a d. Okay, and then I check, what did I multiply by here? I multiplied by 5c, so let's multiply the top by 5c. And then, what did I multiply the second one by? It looks like 3, so I'm going to multiply this by 3. Okay, so that's sort of the initial step. Let's multiply through the brackets, 15c squared minus 10c. And then we're going to get to the oldest trick in the book where the math teachers try to fool their students. Okay? You need to remember this is a subtract. Alright, this is a negative 3. At least that's how we'll treat it. So it's going to be negative 3c take away 24. Okay, the number of times I've seen that sign incorrect, boy, if I got a nickel for every time that happened, I'd probably have quite a few more nickels. Okay, so we're almost done. Let's clean this up. 15c squared minus 13c minus 24 over 15c squared d. Okay, c cannot be 0, d cannot be 0. Alright, I'm not going to check to see if it can factor, because even if I could get two factors like this, it wouldn't reduce with anything here. Okay, so I'm going to leave it for now. Won't be able to reduce that at all. Alright, do a few more. So we've got three fractions, and what is the least common denominator here? Looks like 24a squared. Okay, so I multiply the 5 by 12a squared. I multiply the 3 by 6. And I multiply the 3a by 8a. multiply the 2 by 8a. So I get 60a squared minus 18 plus 16a all over 24a squared. Okay, and I have 60a squared plus 16a minus 18 over 24a squared. A cannot be 0. Now, I don't know if any of you noticed, but I actually did not find the LC, the least common denominator, right? I should have found 12a squared. Okay, so I didn't find the least common denominator. What does that mean? Well, if you look in our final answer, we can simplify. Okay, so we need to divide each term, looks like, by a 2. Okay, so if I divide everything by 2, I'm going to get 30a squared plus 8a minus 9 over 12a squared, which should have been my least common denominator. It should have been 12a squared. Okay, so what's the moral of the story here? Make sure that when you're doing this, you find the least common denominator. In this case, we can figure it out later. We can simplify it. But as soon as we get into binomials in the denominator, you can't simplify it at the end, and it just gets really, really ugly. Okay, so I want to stress again, we're trying to find the least common denominator. Okay, last question we will do for this lesson, I think. Yep. Alright, let's be a little more careful this time. Let's find the least common denominator. I think this time it is 24 z squared. Okay, and what did we multiply the first fraction by? Looks like a 3. Now, if you don't want to write this step, if you want to, expand that right away, for sure you can do that. Okay, if you can do 8 times 4z minus 4 in your head, that's fine. Okay, so I get 6z plus 3 plus 32z minus 32 minus 32z squared plus 4z cubed all over 24z squared. By the way, please write the denominator each time. Don't skip a couple steps where you just want to deal with the numerator. Okay, you have to write, the second we put equals, this line has to equal that line. So if you decided not to write this and just left it like that, even though you know you're going to put it in at the end, that will cost you. Okay, let's simplify. 4z cubed. Okay, and then I'm looking at, are there any z squareds? Looks like 1. And then 32z and 6z plus 38z. And then minus 32. Is that right? Oh, no, not 32. 35. 29. Okay, and divide by 24z squared. Alright, and I see there, because this is an odd number, I can't divide anything by 2. I don't think anything else can be simplified there. So we're done. Okay, so please go to page 553, numbers 3, 5, and 6 to 13. Okay, good luck.